For 4 trigonometric functions of any angle. Objectives. You can pause to read them, but I am moving on. Vocab and key concepts. There's only 2. You can pause to read them, but I am moving on. Let me read this to you. Definition of trigonometric functions of any angle. Let theta, use the pen, let theta be any angle in position with x, y, a point on the terminal side of theta, and r equals the square root of x squared plus y squared. And this cannot equal 0 because we would be undefined. Now notice that this theta is not necessarily acute, it's obtuse, and not only that, the radius is not going to be 1 anymore. It could be 1, but it might be larger than 1. So we're no longer we don't necessarily have to be in the unit circle. So this is what you need to memorize or understand where it's coming from. I'm moving on to the next slide. And again, hence more restrictions. Cannot equal 0, y cannot equal 0, and so forth. Why? And I think you can tell me why. We would have undefined. That's why. Moving on. Definition of a reference angle. Let me read this to you. It says let theta be an angle in standard position, which we have here. Its reference angle is the acute angle theta prime. This is how we read it. Theta. This little comma thing. Call it. We read it as theta prime. Formed by the terminal side of theta and the horizontal x-axis. Here's the horizontal x-axis. Let me change the color. So what is the theta prime here? From here to here. This is your theta prime. Another example. This is your theta. So your reference angle is again, the reference angle is the acute angle theta prime formed by the terminal side of theta and the horizontal axis. So the angle has to be acute and it's gonna come from the horizontal axis. So it's from here to here. And notice that this angle, it is acute. So this is your theta prime. Moving on to the next one. By now, you should have an idea that this is your theta prime. Okay, moving on to the next slide. First example says determine the exact values of the 6 trigonometric functions of the angle theta. So I have this, and this is what I need to do. I need to use the definition that I saw earlier on the slide. Trig functions of any angle. So then I should be able to compute r using the formula that I have there. And I get 13. And then at this point, I'm just going to follow the definition. Sine is going to be y over r, and I get negative 5/13. Cosine is going to be x over r, so I get 12 over 13. Tangent is going to be y over x, and I get negative 5 over 12. Cosecant is just a reciprocal sine. Secant, reciprocal of cosine, reciprocal of tangent. And notice that the radius, again, is no longer 1, now it's 13. So we're not in the unit circle. Moving on to number 2. The point is on the terminal side of an angle in standard position. Determine the exact values of the 6 trigonometric functions of the angle. So they don't give you a picture here, but you should be able to see that this is in quadrant 3. And the r is equal to the square root of 61. So at this point, you apply that, what you saw on that slide earlier, trigonometric functions of any angle. That's how you get sine of this angle, cosine. And notice that we have to rationalize here. We have radical 61. You should be able to see why we get this. Cosine Same thing, rationalize. Tangent, you don't have to, but we get 6 over 5. You can tell me what goes here. Same thing here. Same thing here. I'm going to be checking for this on the notes. Make sure you give me the correct answer. Don't leave it blank. Moving on to number 3. So state the quadrant in which theta lies. So we have secant of theta is greater than 0 and cotangent of theta is less than 0. This is what I want you to remember. It's not easy to generate. If you need assistance, let me know. But this is basically telling you that the sine of theta in the first quadrant is always positive. Cosine of theta on the first quadrant is positive. Tangent of theta is always positive. So follow for quadrant 3, follow for quadrant 4. So now, since secant of theta is greater than 0, I know that cosine of theta is 0. It's reciprocal. And I have the cotangent of theta is less than 0, which tells me the sine of theta is less than 0. Because if cosine is positive and is cosine over sine, this is one of the quotient identities, I know that sine has to be negative because it's less than 0. Which implies that this is in quadrant 4. Refer to what we have here, and you should follow why we have quadrant 4. 4, tangent of theta is greater than 0, cosecant of theta is less than 0. From here, since cosecant of theta is less than 0, I know the sine of theta is less than 0. Now, tangent of theta is 0. And remember, quotient identities is sine over cosine. And sine is already less than 0, and tangent is positive. You know that. Cosine is also less than 0. Which quadrant do these two lie? Right here, so it's quadrant number 3. Moving on to the next slide. This one is a little bit different, but nothing that is not doable. So here we go. It says the function value is cosecant of theta is equal to 4, and the constraint is that cotangent of theta is less than 0. You should know that cosecant of theta is r over y. That's why I have this. And then I can find x by using the Pythagorean theorem, or what you saw on that earlier slide, the trigonometric functions of any angle. So then I have, since cosecant of theta is equal to 4, that means that cosecant of theta is greater than 0, and cotangent of theta is less than 0. This implies that we're in quadrant 2. And this is what we did on the previous slide. You should be able to follow. Talk to me if you need assistance with this in class. So from here, I know the sine of theta is equal to 1 over 4. And notice that this is positive, because sine is positive on the second quadrant. Cosine of theta is negative, because we know it's negative on the second quadrant, and it's radical 15 over 4, and again negative because in the second quadrant. Tangent of theta is also negative, and is y over x. Rationalize, this is what we get. Secant of theta is the reciprocal of this. I rationalize. Cotangent of theta is the reciprocal of this. This is just like number 5. Same directions, different values, but the function value of sine of theta is equal to 0. And this is the constraint that theta is on basically second and third quadrant. Notice it goes from pi over 2 to 3 pi over 2. So if you look at this picture, we're somewhere here. Second quadrant, third quadrant. Now, where do you have sine of theta equal to 0? Between quadrant 2 and 3. And that is here, exactly at pi. That's where we have sine of theta is equal to 0. So now that we know that theta is pi, we can compute the other 6. We know that cosecant is 1 over sine. Get the pen. So I know I have this, and then I have 1 over 0. If I get the reciprocal, that's how I get undefined. Cosine of theta, but what I know that theta is equal to pi, that's how I get negative 1. Tangent of theta is 0 over negative 1. Again, is x over, or sine over cosine. That's how we get this. Secant, reciprocal this. Cotangent, reciprocal of tangent, and that's how we get, I forgot the equal sign here, equals undefined. Says evaluate the sine, cosine, and tangent of the angle without a calc. I'm going to go a little bit fast here, but you can draw this. Notice that this is a negative angle, and this is what you get. And this, in this case, I'm going to be using reference angle. So then I'm looking at this right here, the reference angle, which is going to be 45 degrees. That's your theta prime. Okay, so then I'm going to compute sine of 45 degrees, cosine of 45, and tangent of 45. And notice this is just the reference angle. So sine of 45 is radical 2 over 2, cosine is radical 2 over 2, tangent is 1. But this is only the reference angle. Now I'm going to take into account that I'm in the third quadrant. So what happens to the sign here of sine, cosine, and tangent? I know this sine is negative, cosine is negative, and tangent is positive on the third quadrant. Moving on. Use the given value of the trigonometric identities to find the remaining trig functions of the angle theta. So they give you cotangent of theta equals negative 5 and sine of theta greater than 0. So this is what I want to do. I'm going to compute this a little bit different. You don't have to do it this way. You can apply what you saw on an earlier slide. I believe it was problem number either 7 or 8. But anyway, I'm going to actually use the trigonometric identities. So then, this is what I'm going to do. I know that theta is in quadrant 2. Why? Because we did something like this earlier. And if you want me to clarify this, talk to me in class. I know the tangent is 1 over cotangent. I know that I'm giving cotangent is negative 5, so that's how I get tangent of theta. It's one of the trig identities. Moving on, secant of theta, if I apply the Pythagorean identities, I have this. And then at this point, I substitute tangent, which is this, and this is what I get. But I have to be careful here because I'm in the second quadrant. Once I simplify this, I get the following. Radical 26 over 5. But again, this is secant. I'm in the second quadrant. What am I missing? Negative. I cannot forget about this. Since I'm in the second quadrant, it has to be negative. Cosine is just going to be the reciprocal of secant. We already computed secant. And it's also negative on the second quadrant. And rationalize. Sine, I'm going to compute a little bit different. If you compute tangent theta times cosine of theta, you should be able to see that we get this. Excuse me, I already know that I have tangent, which is here, cosine, which is here. So I just multiply those two, and this is what I get. Moving on, this is my answer. And for cosecant, it's just the reciprocal sign, and this is what we get. This is the end of the video.